Welcome, everyone. Thank you for joining us today in automated verification of deployments. My name is Gopinath Rebala. I'm co-founder and CTO of OpsMx. Today, we will discuss what is automated verification and how can one use it in the current delivery pipelines. We will go a little bit of background on how it works and then do a demo of automated verification of using a pipeline based on the analysis promotes to production. And then we'll leave some time for Q&A. So who are we? We are OpsMx. We are leading continuous delivery solution provider. So our vision is to deliver software without human intervention. For that vision, we work with Spinnaker. We have a product called OpsMx Enterprise for Spinnaker. We are one of the core contributors to the Spinnaker community. And and we also have a product called Autopilot, which is essentially the product for continuous verification. This is what we will discuss today in terms of the demo and the background of it. So why do we need automated verification? Right? In 2017 study, Gartner study, it found that as organizations try to increase the velocity of their delivery of software, the failures significantly increased. So as some of these organizations reached hourly delivery, all of their deliveries were failures. So the cost of the failed delivery is really high. Essentially, if you find problems at tail end in the production, the cost is much higher than you would find in the testing. So given that this model was not working, but that was 2017, now with the conversion to microservices and adopting cloud environments and automated delivery systems like Spinnaker, there is a significant improvement in the way small changes are being delivered continuously to target environments. The magic essentially lies in this ability to do small changes on a continuous basis to deploy for the applications. So this essentially decreases the cost and makes the mean time to recovery a lot faster for recovering from small changes. But it still requires deployment strategies and continuous verification. So why? If you look at current delivery mechanisms, they're generally organized as a continuous integration and continuous delivery. In the continuous integration, you have the build and unit test and maybe static code analysis that you do, but then you hand it over to the delivery mechanism, which has a certain number of steps in it, where you deploy in test, run the test, maybe run the dynamic code analysis and go through some approval process, and then deploy to production using some deployment strategies. So at each of these stages, the decisions that are made to say whether that software can be promoted to the next stage are done manually. So today, the manual approval and verification gates that occur at different stages are based on some judgment calls one makes. Either in the DevOps model, the developer, after the test moving to production, it could make a different decision based on the results, whether it occurs on a Wednesday morning versus Friday evening. Right? These are not consistent results because of decisions they're making. And it also has the manual stages where someone has to approve, let's say, for example, doing a Sarbanes-Oxley kind of systems. For them, they need the visibility into all the audit compliance data as well as the test data to make that call in allowing that promotion to happen. And usually these are siloed visibility and intelligence. And in the microservices world, in the product, there are large number of services that are coming in. Not everyone is expert on all of these, and by simply looking at one service that is being promoted does not give them full visibility into the functionality and the performance of the impact of that in production. So for all of these, it makes the current manual verification process error prone and also starts introducing delays because there is no confidence in it. So there is a certain amount of delay that gets introduced for every decision that is going to be made. So to counter that, you actually need this automated verification. Uh, in a multi-service environment, as you're promoting your services, it's not just the service that you are promoting that you need to look at the logs or the metrics that are being generated by that service, that you need to verify everything is good, but you also want to see the entire ecosystem of the product and all the dependencies and make a decision on whether the service can move forward. Typically, you have these SLOs that you look at once you promote the service and say everything is good. And as a secondary thing, you also look at logs of the system. And now looking at these logs in these services with the Spring Boot kind of systems, they generate humongous amount of logs. And looking at all of these to find anything new that could be causing a problem, either in terms of architectural regression or compliance issues or anything related to scalability, are very hard to find. So this is essentially the core drive towards going for the automated verification. Now, where can we plug in this automated verification? What does it need to support this? In a typical delivery workflow, you have your artifacts built and go through the integration test, load test. And then there are gates there, depending on the P1 issues that you see or what the functionality is, you decide to promote to staging. And once you promote to staging, there are additional gates there based on the environment and configuration that you have set up. There are no new functional issues or performance issues. And then you can use the deployment strategies like canary or blue-green or rolling update, and then decide if something needs to be rolled back or stay in the production. So at each of these gates is where you can look at the digital exhaust and determine you can use the automated verification here. So the digital exhaust here essentially refers to the logs and metrics that you're providing for each of the services that you are promoting through your delivery pipeline and make a decision based on that data. Right? Because this is automated, it's consistent. It does the same thing on a Wednesday as well as a Friday. And the decisions that you make are auditable, and you can tune them depending on how it performs over time, and there's a learning that gets involved into it that's codified. So where can we integrate this one? This automated verification is a REST service that you can call from a simple script or integrate into any of your delivery pipelines. Whether it's a Spinnaker or if you're using Jenkins today or any other delivery pipeline that you use, you can integrate that as a REST service to trigger off your analysis as you do the deployment, either in testing, staging, or production. And based on the score, you can decide whether you go forward, and the score you can retrieve based on the API. Okay. So how does it actually work? This is a model is very similar to what you would see with any of these machine learning models. You observe the data that is coming out of your services. The data that is coming out are the log files from your software, multiple services, or the metrics that you're measuring in terms of your SLOs, or even the system metrics. All of them are part of the data that we observe. And based on the data, over a period of time, you can build a profile for that service, and that's aligned with that service. And then this model is continuously updated as we deploy new services. And based on this model, when a new version is deployed, we analyze if there is any deviation that we find or any classification of the logs that we can do as an error. And based on the errors and the metric deviations, there is a score that gets generated. That score is then used for automated decisioning. We also do a deeper analysis in terms of the error classification, which you can use to find specific diagnostic information that helps you in MTTR. So given that, I just want to give a quick demo with this Spinnaker integrated automated verification. For some of you that may not know what Spinnaker is a multi-cloud continuous delivery solution that enables faster deliveries of your software. It provides basically three primary functions in my mind. One is the ability to construct the delivery pipeline at different stages, stitch together a bunch of different steps that you need to deliver. In this case, you can see there is a build stage and test deployment, and then we do an automated analysis based on the test suite that runs against it, and based on the score that we get from automated analysis, we decide to promote to production or stop from promoting to production and leave it for diagnostics. The second thing it does is the multi-cloud cloud integrations. It provides abstractions for each of these clouds for deployment strategies like rolling update, blue-green, and canary deployment that we can build in. But these cloud environments are natively built. So it's not a subset of the features that for each of these cloud environments, but it's a native cloud API called Cloud Driver that you will have. The features that Kubernetes supports are different from features that AWS supports, for example. And these are all built in, takes advantages of what the cloud provides, and then provides an abstraction layer that we can use as part of the delivery pipeline. And the last but not least is this ability to manage your deployments. As you deploy your applications, it helps you look at the current state of your application that is currently deploying, and even act on it based on the RBAC configured with Spinnaker. For example, in this case, you can go back and say, hey, I want to undo the rollout to a previous version or the version before. This is based on the amount of history you keep. This can also be done as part of your pipeline. Say as you do a canary deploy and then decide the canary is not performing, you can do a rollback from there. It also helps you with the diagnosing any errors with services that you deployed. In this particular case, let's say we have a part, we can go look at the logs that gets generated all in one place. You can even scale the deployments or delete these deployments. So given that now for automated analysis, this is a use case where let's say we have a code that we merged into the product branch, and this code is now ready to be promoted to production. But the steps that we want to take are build that code from the master branch, deploy it to the test, run automated analysis against the test cases that it runs, and based on the result that come up, we want to promote to production. So let me redo the same thing. Here, what I'm saying is I want to use this one as my baseline and also don't want any manual judgment. It is possible for us to specify, even after doing automated analysis, to look at the analysis report and make a manual judgment to promote to production. So in this case, we'll skip that. While that one is going on, just want to show the previous canary. So here, previous analysis that it has done, and in here it's actually 100, which is 100 is the analysis is successful, and this is compatible with the previous version. We don't see any specific problems with the in confidence in promoting to production. So 0 is a low confidence, 100 is a high confidence. Then in the case where it fails, and if you want to do diagnostics, most of the times if it succeeds, you don't need to do anything more. You basically promote to production because there's no difference. But in the cases where it fails and we want to go do the diagnostics, we can go to the report and see what the report details and find responses fairly quickly. So let me show you a report that has a failed score. These reports can be used to quickly identify what the issues are. It does the analysis both for logs and the matrix. Here, this gives us scores independently for both logs and metrics. In the logs, it's basically found one error that seems serious enough for us to warrant a stoppage of the promotion to production, and one is to take a look. So here the analysis is done over 100 kilobytes of data for the short period that the logs are generated. This view logs essentially takes us to an external system like the Elastic that you're already using, let's say, for collecting the log information on Splunk, and gets the data from there. So in the logs, in the details, if we go, of the 100 KB of data, it was able to find these lines of data that's are together. It forms a clusters of the logs. Essentially, we're using the natural language processing. It is able to identify log lines that form clusters, both in terms of similarity as well as closeness to each other, and then classifies them as an error or informational, and based on that classification, it computes the score and basically allows us to use that automated score for analysis, decisioning. So it found this error. You can see this is having trouble connecting to the SQL server, and we can also see that the timeline of the test and these errors occurred, or in the beginning part, first 5 minutes of this test, where it hasn't occurred after that. And in the first 5 minutes, it did multiple retries. So it seems like there is an issue where there was initial network configuration error, and it had problem, but it recovered after that. So maybe this is not an issue that we should really worry about unless it occurs again. It may not be the issue with the software. However, if you go and look at the log metrics data, you see that we are collecting metrics for those services. So these can be the application level metrics or the system level metrics, where we find the data coming from operating system or pod level metrics like memory, CPU, and those kind of things, as well as the latency. Here, it found that the latency is high. So clearly based on the previous error and how it recovered, and the latency here, there is a network configuration issue or database latency issue here. So we need to look at. And so in this particular case, what we did was, it was a transient issue at that point. There was a network configuration with the VPC. There was an issue with the routing was a problem. And by correcting that, we were able to identify and fix the issue for this service. The other thing I want to also show is this ability to do multiple services simultaneously. So there in the analysis, in the template, we said, run this analysis for one service. So here, it is possible to run this analysis as we deploy one service on multiple services. And you could provide a number of the services that you know as a dependence and run the analysis, and then we will get a correlated score. And if there are errors that are occurring in service 1 and service 2, we can correlate those errors fairly quickly and identify if there are any dependencies and changes that are occurring that are affecting the entire application. So going back to, it probably takes another few minutes to complete. But as you can see, now we are able to deploy to test environment, run automated analysis that's beyond the test cases that you do. You may have incomplete test cases in some of these functional systems. Sometimes we cannot completely automate all the test cases for 100% coverage, particularly in integration environments. So this is an added benefit where you could automatically test, verify your deployments without having to do any additional coding. It gives a higher confidence in promoting your software artifacts to production. Given that, I'd like to now see if there are any questions and answer any questions that you have. Thank you for taking the time. You can reach out to us at hello@opsmx.com. or reach out to me at gopinath@opsmx.io. And visit our website at opsmx.com for more information. Look forward to your questions now.